Good morning, good afternoon, good evening, or depending on your time and your location. I'm Engineer Moses Unwafi. Lately, some of our followers wanted us to talk more on Atex electric motor design and installation. So today, I want us to understand that an Atex electric motor is a type of an electric motor specifically designed and sanctified for use in potential explosive atmosphere. This term, Atex, comes from French atmospheric explosible and refer to two European Union directives for controlling explosive atmosphere. Atex motors are engineered to prevent ignition of surrounding explosive atmosphere, which could be caused by gases, vapor, dust, and fibers. They achieve through specific enclosure, which means designed to contain any explosive that might occur within a motor, preventing it from igniting the external atmosphere. And also temperature control, which means that ensuring the surface temperature of the motor never exceed the ignition temperature of the surrounding hazardous material. And also by sealing and protection. That means preventing dust or gas from entering the motor. And above all, sanctified components. That means that all parts are tested and sanctified to meet Atex standard. We have to consider also the safety hazardous area. So an Atex motor are required in an industry where flammable gas, vapor, or dust are present. For example, oil and gas refineries, chemical plants, paint factories, pharmaceutical manufacturer. Then in terms of legal compliance in a country like Europe and many other regions, adopt Atex or similar standard as a legal requirement to access certified equipment in classification hazardous zone using a non-Atex equipment in this area is illegal and extremely dangerous. And talking about risk reduction, Atex motors are designed to minimize risk and explosion, protecting both people and properties. What about insurance and liabilities? And using a sanctified Atex equipment is often a requirement for ensuring coverage in hazardous industry. It is also reduced liability in event of accident. I want us to understand that designing and installation of Atex sanctified electrical motor must be approached with a strong emphasis on safety due to the hazardous nature of the operating environment. These motors are typically employed in areas where explosive atmosphere may be present, making a compliance with safety standard critical to ensure both operation efficiency and equipment integrity. By doing so, we have to consider the installations. So therefore, installation process varies depending on the volatile viscosity of the product or liquid being handled by this Atex motor. Environmental conditions should be strictly prioritized during this design, installation, and operation of industrial equipment to ensure safe, reliable functionality of this Atex motor. Specifically, attention must be given to the pump control system, which must adhere to strictly relevant safety regulations. And above all, control device must also be accurate, rated, configured to guarantee reliability of safety and operation. The essential control device to ensure optimal functional and protection of all motor. Several control components are required, including one, the contactors or overload, which means protecting the motor from excessive control. Another part is a time relay, which manage the base operation and sequences. Then we have the soft starter, which reduces the mechanical stress during motor startup. Then the variable frequency drive, which allow the precise speed control and energy efficiencies. Then the shaft monitor, which detects the process of inefficiencies by using the motor powered measuring shaft power output. And device rating and compliance will not be left out. For each control device is an imperative to accurate calculation. It's rating based on the manufacturing specification and is aligned to configure with a motor nameplate or data to ensure compatibility and safety. And also to comply with Atex directive and application standard to mitigate risk and explosive atmosphere. Now, to ensure safety and optimal performance of this motor and associated equipment, it is essential to accurately calculate the relevant control according to operational requirements and manufacturing standard. Why do we have to do that? Let's take, for instance, in this scenario, let's consider an Atex motor that has been supplied for installation. And on it, we have a nameplate. On this nameplate, I want you to understand that on every nameplate, we have a prefix which indicates the flame designation, the number of phases, the installation system design, and also voltage and manufacturer time and date. So there are so many other informations like time rated duty, frequency, and etc. Then how do we calculate this MCB, which is miniature circuit breaker? Before we can know how to calculate this miniature circuit breaker, there is a need for us to know the miniature circuit breaker. A miniature circuit breaker is an automatic electrical switch that protects circuit from overcurrent and short circuit. From the above nameplate of the Atex electric motor supply for an installation within the below information, which were previously on the first slide, it was calculated that a current is 11 amps on the nameplate, and the power is 7.5 horsepower. And 7.5 horsepower, know fully well that 1 horsepower is equal to 0.746 watts. So when you multiply, we have 5.595 kilowatts. Then the power factor from that nameplate, we have 0.8 power factor. Then the voltage range is 415, meaning it's 3-phase. Indicator service, which is service factor, regarded as SF, is 1.15. Now, for us to calculate, there is a need for us to verify the motor's full load current. Now, to verify the full load current, we have to apply a formula for a three-phase motor with current approximately, we have our full load current formula to be P, which is the power output, all over root of 3 multiplied by voltage times the power factors. And when you substitute the power factor, which is 5,595, all over the root of 3 multiplied by 415 is going to give you what? 10.8. Approximately is giving us what? 11 amps. Now, to calculate our miniature circuit breaker rating for this very particular motor that has been supplied to us, there is a need for us to consider the safety factor. And the safety factor of it is going to be 25% as the standard. So when you use 25% to multiply your FLC, which is your full load current, is going to give you 2.75. And now 2.75 add to the FLC, which is your full load current, is going to give you what? 13.75 amp. So 13.75 amp now become the standard MCB rating. And now in an MCB rating is arranged in standard according to IEC to be 16 amp, 32 amps respectively. Now the next of the amperage that you need to pick after having this 13.75 amp is 16 amps. So therefore, we have our nominal rated MCB to be what? 16 what? Amps. Then how do we calculate the contactor rating? Before we can talk about calculating the contactor rating, we need to know what a contactor is. A contactor is an electrical control high power switch used repeatedly to make a break of an electric power circuit, primarily for controlling a high power load like electric motor and heating system. Now, to calculate the rating of this aforementioned scenario, which is the motor that has been supplied for us previously, we use 58% as a safety factor due to the frequent start of this motor, the high ampere temperature, the long cable runs, and poor ventilation on the area that is going to be installed. So by considering that 58% multiplied by our FLC, which is our full load current, is going to give us what? 6.38. And when you add 6.38 to our full load current, it's going to give you what? 17.38 amp. The contactor used in this scenario is now 17.38 amp. Remember that our contactor current, according to IEC, is rated in 9 amps, 12 amps, 18 amps, 25 amps, 32 amps, and 40 amps respectively. And our rating of contactor should be 18 amps because it's far more closer to the range of our amperage, ampacity, which is 17.38 amps. We are not going to stop there. We also have to calculate the overload relay rating. But before we can calculate the overload relay rating, there is a need for us to know the overload. And what is overload? The overload relay is an electrical device designed to protect a motor and other electrical equipment from damage caused by excessive current. The relay monitored the current flowing to the motor. If exceed a safe predetermined limit for a specific time, it trips by sending a signal to the conductor, which separates the device that controls the main power to open the contactor, then interrupt the current to the motor. To calculate the overload relay rating, there is a need for us to consider the standard safety factor. In this scenario, our standard safety factor is what? 20%. And when you multiply 20% as it is on the slide, we have what? 2.2. So 2.2, when you add 2.2 to 11 ampere-city, which is the full load current, is going to give you what? 13.2 amps. Now, our overload relay of 7.5 horsepower motor is now what? Is rated to be what? 13.2 amps. Now, when setting this overload relay, you set it within the range of 9 to 13 amps. And there are other ways to do this. What are the other ways to do this? The other way to do this is for you to consider the indicator service factor. The service factor is always located at the nameplate of the motor that has been supplied. And when you check the service factor in this scenario is 1.15. Then you use the 1.15 to multiply our FLC, which is a full load current. The full load current happens to be 11 amps. When you multiply it, you have 12.65 amps. This 12.65 amp now becomes the amperage of our overload relay rating. Now, in setting this relay rating, you set it within the range of 9 to 12 amps. Remember, some installers always set the rating on the rating of the word FLC. I want you to share this video so that others can also gain knowledge. And I also want you to watch out for the calculations of other devices that are used in controlling a Atex motor in an hazardous area, such as substarter, variable frequency drive. Thank you.